All right, we're recording now. We'll go from current slide. I'm going to go over the announcements first while the projector is coming on. I guess it's coming on. Let's see, things that are happening this week. Today is the 60% completion date for full term, fall term, for Title IV funds. So if you know of anyone who's thinking of withdrawing from a class that's full-term class, it's okay to do now. You won't be having to pay anything back later. I don't see any other things on here, so that needs announcing today. Our volleyball team will be hosting Gadsden State tomorrow evening, Birmingham West Campus, Arthur Shores Fine Arts Building, which is also our gymnasium. That'll be at 6 p.m. Tomorrow evening. And then, I'll announce the rest of that. Okay. Oh, you got to sit in there a plug?
I can still see.
I'm sorry?
I can still see.
Okay.
I have a problem with the body.
Okay. Right, yeah. I know I've had to do the same thing before. All right. Any questions on anything we've done so far? Okay. We started last time, we're in Chapter 3, Determinants, and we started 3.1 last time and started talking about determinants, minors, cofactors, those kind of things. So that's where we're picking up today if there's no questions, and we're going to do example 2. Okay? It says find all the minors and cofactors of this matrix. Let me get my pen set up. Matrix A. Not one of our favorite ways to express them, but it'll be fine. 0, 2, 1, 3, negative 1, 2, and 4, 0, 1. Okay, that's your matrix A. And we want all the minors and cofactors of this matrix. Okay. Now, the minors, this is with ORS, not ERS, there will be 9 of them, right? Because there's 9 entries here. So they will be M11. Well, let's just start with M1. In fact, I think I'll move it on up and do here, because this is probably going to take up most of the room we got. So let's start with M11. What would be the minor for M11, and how do you get it? Okay, you eliminate the first row and first column, and your minor would be, and your minor is a determinant, by the way, okay? It's the determinant of the matrices left over when you do that. Determinant of -1, 2, 0, 1, right? And what is that determinant? -1, okay? And M12, okay? Now, if you don't need me to cross out, well, let's just go and do it for a while because people watching at home might need it. So we'll wipe out row 1 and column 2. What's the minor there? Okay, you're listing it, okay. 3, 2, 4, 1. And what's that determinant? -5, okay. M13, okay. And again, we'll wipe out third column. And what's the minor left over? And what's the value of that? Second? 4. Perfect. Okay. M21. Okay. This is going to be eliminating both of those. And 2, 1. So what you got? 2, 1, 0, 1. And what's that? Two. Perfect. Okay. M22. And this time we'll eliminate the second column. Okay. And what do you have there? Zero, 1. 4, 1. What does that give you? Negative 4. Perfect. Then we'll have M23. And this time we'll eliminate the third column. And what do you have? Second?
Yeah,
8? Isn't it negative 8? Yeah, negative 8. All right. And we got 3, 1. Oh, wait, I don't need that. Okay. Well, I can't get my pen to write. There. Yeah, okay. This thing goes all over the board when you don't want it to. Okay. M3, 1. And at this point we eliminate the third row, first column. And what's that?
2, 1.
Second? 3, 1, yeah. And what do you get?
2, 1.
Oh, 2, 1, negative 1, 2, which is 5. Perfect. M3, 2. Okay, would be
0, 1.
right,
3, 2.
right, and that would be negative 3. Is that what you said? Yep, good deal. And finally, M3, 3. Is 0, 2, 3, negative 1, and that gives us negative 6. All right, and here's Charles. Double the class size. All right, good deal. Thank you. Did you get?
Yes, sir. Thank you.
Okay.
Thank you.
You want the original copy?
Yeah.
Okay. I brought it. I didn't put it on letterhead. I hope that was okay.
No, it's fine.
Because I don't have letterhead, but yeah.
I uploaded it. It went well uploaded fine.
Okay, good.
On the website, so it's good. Thank you.
All righty. And this is test 2. Okay. Before I forget it, I hope I have the key for test 2. My work-study student has made a habit of destroying things.
Hope I did well.
And I see no test 2 key. So I've got to go back and make up another key for test 2. So I'll have to do that later. Hold on. Okay. We've just been doing the minors for this matrix here as example 2, bottom of page 105 in chapter 3, determinants, section 3.1, the determinant of a matrix. We've just listed the minors. They also ask for the cofactors. Now, what is a cofactor? Okay, is the minor, except you put down the sign that's appropriate. Okay, and I call that the sign of the position. Okay, so basically I'm just going to list C11, C12, C13, C21, C22, C23, C31, C32, and C33. And you can just list these based on the minors and the appropriate sign. I left more room in some places and less in others. And that first one's a 1, 1. It looks like a 2, but that's a 1. What is C11? Negative 1. Same as M11 because 1 and 1 is 2. Okay, and that's an even number. Okay, C12? 5. Because 1 plus 2 is 3. That's an odd number, so you change the sign. Okay, C13? 4. C21? Negative 2. C22? Negative 4. C23? 8. C31? 5. C32? 3. And C33? Negative 6. You don't change the sign of that one because the sum of those is even. All right, let's see how the book did. M11, they got a -1. 1-2, they got a -5. 1-3, they got a 4. 2-1, they got a 2. 2-2, they got a -4. 2-3, they got a -8. 3-1, they got a 5. 3-2, they got a -3. And 3-3, they got a -6. Good for them. So the C11 was -1, 5, 4, -2, -4, 8, 5, 3, -6. Yes, they got them right. Good for them. Now, when I was listening like this, it's pretty easy to just look at the numbers here and then know whether they're even or odd. Most of the time, I'm not doing that. I'm looking at the position. And we talked about that. It's a plus, minus, plus, minus, plus, minus. Yeah. As long as you're going right, left, up, and down, you just change the sign every time. Do not go diagonal with it. Okay, that gives you wrong answers there. Okay. And they give sign pattern for 3s, 4s, and n by n matrices there on page 105. All right. Now, page 106, any questions on this one? This example we just did. Okay. Page 106, the title at the top of the page, the determinant of a square matrix. Well, guess what? Square matrices are the only ones with determinants, so why do they say that? Okay. The definition below is called inductive because it uses the determinant of a square matrix of order n-1 to define the determinants of a square matrix of order n. Okay? Now, I still can't figure out why they specify square matrix, because they all have to be square matrices. Okay? I guess I'll write this because not everybody has books. So I'll write out this definition in my ugly abbreviated script. Okay? If A is a square matrix, got to be to have a determinant of order greater than or equal to 2. Okay? Or n greater than or equal to 2. Now, they have a little note on the side, a remark. The determinant of a matrix of order 1 is simply the entry, because it only has one entry, and that will be its determinant. Okay? For instance, if the matrix A is the number -2, that's all it is. A 1 by 1, -2, then its determinant is -2. You can't do anything else with it. It's on the diagonal, and those, you just use it. Okay. So, we're doing order n greater than or equal to 2. Then the determinant, I'll abbreviate like crazy. The determinant of A is the sum of the entries in the first row I sort of don't like this, but I'll tell you why in a minute, of A multiplied by the respective cofactors. Okay. That is, the determinant of A is equal to the sum of, when J is going from 1 to n, now remember n is the order of the matrix, so you're starting with first, and they list it as A1J, where 1 is indicates it's in the first row, times C1J, the cofactor of that, and you go through all your J's, and that's what you get, which is A11 C11 plus A12 C12 plus A13 C13 plus ... all the way up to plus A1N C capital C1N. Okay. That's it. Now, a 2 by 2 is real easy because it's just two by 2 only has the 4 elements in it. So A11 times its cofactor, which is A22. Okay, that's all that's there. Okay, and then you do plus A12, which is this one, times minus C12, the cofactor down here, because that's the negative value. And then you don't have any of the others, you've done it. So that's what gives you that. Okay? Now, here's what they're going to talk about this later and fine, but I just want to say it now, just to keep you from getting fixed in your mind that this is all, that's all there is. It's not. All this is fine. The determinant of A is the sum of the entries in any row or any column of A multiplied by the respective cofactors. It doesn't need to be the first row. It doesn't need to be the first column. Any row, any column. And we'll get to that later, but they're just starting you off with the simplest now. so to speak. Okay. And then it says, when you use this definition to evaluate a determinant, you are expanding by cofactors in the first row. Okay? So we're going to do example 3, which uses the same matrix as example 2. So it doesn't hurt to redo it, but I'm going to, at the same time, show you the easier way to do it. Okay? So here's the matrix A is 0, 2, 1, 3, negative 1, 2, 4, 0, 1. Okay? Now, if I were doing this from scratch, okay, here's what I would do. Now, we're going to use row 1 because they want you to, okay? But row 1 is probably the easiest row to do, okay? Column 1 would be easy too, but the numbers are a little bigger, okay? Row 3 would be pretty good. It's still bigger than row 1. And column 2 would be easy. And there's a reason for that, because of those zeros. So you pick the row or the column with the most zeros in it. That's the one you zoom in on. This one there's only 1 0 here, 1 0 here, 1 0 here, 1 0 there. The rest of them have, 2 zeros. Okay, no zeros. So focus on these. These have the smallest numbers. I'm perfectly happy to do that. So you see, if you pick this as your first entry, it's going to be 0 times whatever you got. The cofactor of this. Who cares? Because it's 0 times it. So here's how I do it. And I don't really think in terms of minors and cofactors, though I'm using them. But here's what I do. Okay? I see this 0 there. I know that result's going to be a 0. Go to the next. We're using the first row, so let's use the next. In fact, since we're using the first row, I'm going to go on and put my line through it. 0 produces nothing. 0. Okay? Nothing. First thing I ask myself, what is position of 2? It's a negative. So it's going to be negative times, and since you're using 2, we'll wipe out that 2, the determinant here. So this would be negative 2, because of that, it's in the negative position, 2 times, now do the determinant here. 3 minus 8 is a negative 5. Right? So I don't think of cofactors or anything like this. What I think of is my sign of the position. Okay? So if I'm using the top row, that gave me nothing. This is a negative position, so negative 2 times the, and I guess I don't call it a minor, but that's what it is. Okay? So that's 3 minus 8 is negative 5. Okay? Now move to the next entry. The first entry gave us nothing. The second entry gave us that. I can't get my eraser to come up. Okay? Leave the first one wiped out there because you don't need that. Okay? You're using that first row. Now we're using this one. What is the sign of my 1 there? Not the sign of the actual 1, but the sign of that position. Positive. So that's 1. So it's just going to be plus 1 times. Now, just do this determinant. And what do you have there? 4. Okay? So what do you have? 10 plus 4, 14. There's the determinant of matrix A. That's it. The determinant of matrix A is 14. Okay. Now, the book's not doing this yet, but let's us do it just because it's fun to do. I know, because just to convince you of what I said was true. Okay? Let's pick the first row and do that one. Okay? So let's do this one. The 0 still gives us nothing. Okay? The 3 is in what position? A negative, so that's going to be a minus 3. Determinant of A is going to be minus 3 times the determinant of what's left, and that's 2, right? All right. Then let's go to the next position, and that's going to be the 4. What's its sign? That's going to be positive, so it's going to be plus 4 times the determinant here. And what's that determinant? 5, okay? 4 plus 1 is 5. So what do we have? Minus 6 plus 20 equal 14. There it is. It doesn't matter which row, which column you use. Keep up with they call it the cofactors. I call it the sign of the position, okay? And then it's the minor that I'm doing, but yeah, that's all it is, okay? Let's use, since this is so much fun, let's use, you want the second column or the third row? I don't care. Second column or third row? You choose. Second? Second column. Okay, we'll use this one. Okay, it's going to lead off with that 2. What's the position of the 2? Okay, so it's going to be a negative 2 times the determinant of what's left. Since we're using 2, we'll wipe out the first row there. And that is help me. 3. No, you multiply. Okay, 3 minus 8, because that's 3 minus 8 is negative 5. Okay, and then we'll go to the second position, the second one, which is the minus 1. Okay, let me erase what I need to erase here. Okay, and what position is that minus 1? What's the sign of that position? Plus, minus, plus, right? So it's plus a minus 1, which is a minus 1. And then we'll wipe out that row, 2. And what do you have left?
You have 4 and 1.
Okay, you have a 0 coming down,
Oh, okay.
minus a 4 going up, right? So that's a negative 4. Your down diagonal is positive, your up diagonal is the negative. So it's 0 minus a 4. So what does this give us? Positive 10 plus 4. 14 again. Okay, it must be that. You want to do that last one? I'm just doing the easy ones. I'm not doing all the hard ones. Okay? So let's do the third row. Okay? So we're going to use this one, and we're going to start with the first column. So what is the sign of that 4? Of that position where 4 is? Positive. So that's going to be a 4 times, let's do its determinant. And what do you have there? 5, because it's 4 minus a minus 1, which is plus 1. That'll be 5. And then I'll erase those. It's so easy to do with my magic pen. Ooh, I erased too much. Y'all gonna have to tell me what number I just lost. 3. It was a 3. Okay. So next, that 0 is going to give me nothing. So then I'm going to go to the third column. What position is that 1 in? Nope, not negative. Everything on that main diagonal is always positive, because it's a 3, 3 that adds. Okay, so that's going to be a plus 1. And I mean, just count them and see. plus, minus, plus, minus, plus, okay? Any way you get there. Plus, minus, plus, minus, plus, plus, minus, plus, minus, plus, plus, minus, plus, minus, plus, plus, minus, plus, minus, plus. However you get there, as long as you go right, left, up and down, don't do diagonals, okay? Then that gives it to you. So it's plus 1, and then what you got here? 0 minus what?
0 minus 1.
Where do you get minus 1? Oh, 0 times a minus 1, that's 0. Okay, got it.
Plus, is it 2 times 3?
2 times 3 is?
6.
6. So it's 0.
6.
No, minus 6, because this is your up diagonal. Change the sign. So that would be times of minus 6. And 4 times 5 is 20. Minus 6 is 14. It must be 14. Now, we could do ones with all numbers in them. They're still going to give you 14. Believe me. Okay, trust me. Okay, as somebody says. Okay, let's not. Okay, 14 is your answer. And guess what? They did it. They did a couple with, or at least one with, without zeros in them. So it doesn't matter which one you do. All right. All right to erase? Okay. Now, let's do theorem 3.1. Expansion by cofactors is what they call it. Okay. Just like before, let A be a square matrix. Guess what? If it's not a square matrix, you can't do a determinant. There is no defined determinant. Of order n. Okay. They don't even say greater than 2 now. Greater than or equal to. Then, the determinant of A is given by okay. The summation of j equal 1 to n. Now, this time they're being more general. Aij, Cij, which is Ai1, Ci1 plus Ai2, Ci2 plus Ai3 times Ci3, that's an I there, plus dot, 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 all the way up until you get to Ain times Cin. Okay? Just like we did before, except now you're not limiting it to first row. Any row. I can be any one of the numbers from 1 to n. Any number. But you just keep that one row that you're doing. Or the determinant of A is the summation of I equal 1 to n. This time we're going to let the i's vary, which number your rows, but you're going to keep, you pick a j, any column, and do this. So that's going to be Aij, Cij, which is A1j, C1j, plus A2j, C2j, plus A3j, C3j, plus dot, 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 plus all the way up to A sub nj, C sub nj. Okay? This is just a pick a column, any column, the jth column, and then sum up your ith entry in that column, in that jth column. The first entry multiplied by the cofactor of that. Now, do you have to go through and call it a cofactor? No, you just do the math, okay? Yeah, sorry. When expanding by cofactors, you do not need to find cofactors of 0 entries, because if that entry is a 0, if any one of those a's is a 0, that whole term gets wiped out, okay? So the row or column containing the most zeros is usually the best choice for expansion by cofactors, which is what I already told you. So let's do example 4. Just because it may take a while, I'll erase this. Anyone need this any longer? Okay. Okay. Here's a new matrix A. Uh-oh, SpaghettiOs. This is going to be much bigger. 1, -2, 3, 0. -1, 1, 0, 2. Zero, 2, 0, 3. And 3, 4, 0, -2. Okay. Now, you want to find the determinant of A. What would be your approach? Yeah, third column, that 3 up there. And that's the one we're going to expand by, because it has the most zeros, okay? Now, first, the next question you ask yourself, what is the sign of that position where 3 is? It's a positive place. So that would be a 3 times the determinant of what's left over. So wipe out that row and column, and the determinant of what's left over is a -1, 1, 2, 0, 2, 3, 3, 4, -2. Okay. You still got another determinant to do. Okay? So, where would you go now? What's that? Yeah, which one? Okay, I see 1 row and 1 column with 0. Which are you want to take?
The easiest one.
Okay, they're both pretty easy. Which one would you choose?
I guess
First column?
yes, sir.
Yeah, okay. Either first column or second row. First column is fine. So this will be, don't forget your 3 there. This is going to be 3 times, okay, we're going to do first column, you said, right? What is the position of that first, what is the sign of the position of that first entry? Positive. So it doesn't change sign, so it's going to be a -1, and we'll wipe out that row because we're using it from there, and then we can do the determinant of that. What is the determinant of that? -4. Did y'all give an answer? You may have, I couldn't hear. -16. -16. Perfect. Okay. So we've done the first. The 0 is going to give us nothing. So then let's do the, going to keep that and that. Okay. Third row. Okay, first, what's the sign of that position where 3 is? Second? It's a plus, so it's going to be +3 times, and what's the determinant of what's left over? negative 1. Because it's a 3 minus 4 is negative 1. Okay, this is going to be 3 times a 16 minus 3, which is 3 times 13, which is 39. So there's the determinant of that huge matrix there, that 4 by 4, done relatively easily, right? All right. Now, I think coming up pretty soon, I'm going to show you one other little shortcut. 2 by 2s, easy to do. You don't have to worry about cofactors, minors, anything else. You just crisscross, okay? Just remember it's down diagonal positive, up diagonal negative, okay? Those products, okay? But an alternative method is commonly used to evaluate the determinant of a 3 by 3 matrix. So let's do the one we have up here. They show you with letters. I'm going to show you with numbers, okay? It just makes more sense. This one we just did here that came up with a 13, right? Don't count the 3 in it, just this. So we're going to do the determinant of this one. Negative 1, 1, 2. Okay? 0, 2, 3. 3, 0, negative 2. Okay? Now, I'm going to do something that makes it look like it can't have a determinant. But all I'm going to do is copy the first 2 columns. Negative 1, 0, 3, 1, 2, 0. Okay? Just copy the first 2, and here's what we're going to do then. To get the matrix of, what you want to call this, let's call this C, let's just call it C, okay? We'll call this matrix of C, okay? We know what the answer is, 13. I'm going to show you another way to do it. So the determinant of C is going to be this. When you write them out this way, draw your down diagonals, right? And multiply all those entries together. And what does that give you? Second? 4. Because you see you have 2 negatives. 2 negatives make a positive. 2 times 2 is 4 times 1 is 4. Okay? Let's do the next down diagonal. What does that give you? Plus 9, because again, diagonals are plus. And then the third diagonal gives us 0. Okay? Now we do our up diagonals, but up diagonals are negative. So the first up diagonal is going to be what? Minus 12, right? Next up diagonal is going to be no. I have a problem here, Houston. I don't know what I've done. Have I copied something wrong? That's going to be a 0 because you're multiplying these, and that's going to be a 0. Well, I get 1 there. I did something wrong. Did I copy something wrong? Negative 1, 3, 0, 3, 1. Oh, that's a 4 down there. That's not a 0. Duh. Okay. I knew I must have copied something wrong. That's a 4. Okay. All right. This up diagonal is going to be what? Positive 12. All right, that's working out. And the last up diagonal is going to be 0, right? Well, plus 12 minus 12 adds to 0, and that gives us 13, which is exactly what we got there. To me, this is easier with a 3 by 3, but that's the only one it works with is a 3 by 3. So a 2 by 2 is easy. A 3 by 3 is not quite as easy, but it's pretty easy. But then the rest of them you have to do what we were just doing. Okay? Once you get down to a 3 by 3, stop and do it this way. Don't keep carrying it on. That makes it better to do. Okay? Any questions on that? Now. All right to erase? Okay. Bless you. I've got a cough too. Find the determinant of this A. And again, it's going to be a 3 by 3, 0, 2, 1. Have we seen this before? 3 minus 1, 2. 4 minus 4, 1. I don't remember if this is exactly the same one we've seen before. It sure starts off that way. Let's turn back a page. Nope, not quite. The last line's different. Okay. I thought that didn't look quite right. So if we're going to do the determinant of A, and what I'm going to do, I'm going to cheat a little bit to keep from copying that down. I'm going to make this the determinant here. And what's my first step? Don't subtract. You repeat the first two columns. You can do it any way you want to. Last time I just wrote the columns. This time I'm just going to do the first two entries. 0, 2, 3 minus 1, 4 minus 4. Just repeat those. Okay? Just the first two, not the third one. Okay? Now we do our down diagonals. What's the first give us? Help me. No. First down diagonal is what? 0. You're absolutely right. Next down diagonal. 16. Next down diagonal. Minus 12. Perfect. Now your first up diagonal. But it's a minus because it's going up, so that makes it plus 4. Yeah, remember? Plus 4. Okay, next up diagonal. 0. Okay, next up diagonal. Second. But it's going up, so it's going up. So it's a minus of that.
Oh, I see. I see the connection. Yeah, negative 6. Okay.
Yeah. It is a 6, but because you're going up, it changes sign.
It's increasing.
Yeah. Okay, yeah. The down diagonals are whatever sign they give you, the positive of those. The up diagonal is the opposite of whatever sign you get because it's a subtraction. Just like it is in a 2 by 2. Down is positive, up is negative. Okay? Now, we combine these together. The positives are 20, and the negatives are 18, so this gives us 2. There you have it. And sure enough, that's what we got, 2. All right. Now, the little blurb at the bottom of page 108, okay, almost is not fair, okay, because this course is supposed to be after you've had Cal 2, not necessarily Cal 3. Now, I know Charles has had Cal 3. Have you had Cal 3? Okay, both of you have. So you're okay. I don't know about Peyton. He probably has enough of this to know if he's going to do any of it. But the blurb at the bottom requires you to know about partial derivatives, which usually shows up in Cal 3. Okay? Now, what it is a diagonal process illustrated in example 5. Is valid only for matrices of order 3. Okay, I'm sorry. That's talking about what we just did. Okay? Diagonal process, that's what we're talking about. What the linear algebra implied starts on the next line. If x, y, and z are continuous functions of u, v, and w, with continuous first partial derivatives, which we haven't done yet, but y'all have, then the Jacobians, j of uv and j of uvw, are defined as the determinants, and here's what they are. Jacobian of uv, where you only have a 2 by 2 dimension, you might say, matrix. Okay? So that's going to be the matrix of the partial of x with respect to u, partial of x with respect to y, I'm sorry, v, getting my variables crossed up. Goodness, I'm getting so hungry I can't stand it. Okay. Partial of y with respect to u, partial of y with respect to v. Okay. All right. The Jacobian, and by the way, well, we'll get back to that later. Let's go with the Jacobian of a 3 by 3, which would be UVW, would then be the determinant of the 3 by 3, partial of x with respect to u, partial of x with respect to v, partial of x with respect to w, partial of y with respect to u, partial of y with respect to v. That's ugly. And partial of y with respect to w. And this is goodness, I can't read my own writing. That's a z. The partial of z with respect to u, partial of z with respect to v, and partial of z with respect to w. All right. One practical use of Jacobians is finding the volume of a solid region, and in section 3.4, which is coming up later, you'll study a formula which also uses determinants for finding the volume of a tetrahedron, like you see in the picture there. In chapter 3 review, you're asked to find the Jacobian of a set of functions. Okay, so that's off in the future. Review exercises pages or numbers 49 to 52. So that's all we're going to do on it now. But you have to remember, and I didn't write it all out, perhaps I should have, x, y, and z are continuous functions of u, v, and w. So u, v, and w are your independent variables. X, y, and z are what they usually call intermediate variables, but it's not listed exactly what's your dependent variable. Maybe they are, maybe Jacobian, I don't know. But this is how you do it. Don't sweat it. We're not doing that yet. I don't know if we'll even get to that. But let's go to new topic for this section, but it's an old topic for us. Okay? Triangular matrices. Remember, we have two types of triangular matrices. What are they? So, upper triangular, lower triangular. Okay. A square matrix is an upper triangular matrix when it has all 0 entries below the main diagonal. Okay? So remember we called them U before. That would be something where you have a value, 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 a 0, 0, 0, 0. If you could, that's an upper, no, yeah, that's an upper, no. I knew something looks fishy there. That's a 0 there. I mean, that's a value here. Value on your main diagonal and everything above it. Whereas your lower triangular matrix would be a value 0, 0, a value, value 0, and a value, value, value. The things, the main diagonal and below are where you put your values. Okay. Now, to find, they introduce one other. A diagonal matrix would then be this. Value 0, 0, 0, value 0, 0, 0, value. That is what we call a diagonal matrix. It's both an upper diagonal and a lower diagonal, which means the only entries are on the diagonal, okay? A matrix that's both upper and lower diagonal is called a diagonal matrix. Okay, to find the determinant of a triangular matrix, whether it's upper, lower, or diagonal, it's really easy to do. And let's just do one and see. In fact, I think I'll erase these. My stomach is growling. Okay. Here's matrix A. 2, 3, negative 1. 0, negative 1, 2. And 0, 0, 3. What kind of matrix is that? Second? It's a triangular matrix. Which one? Upper triangular. But any triangular matrix is going to work the same way. Okay? Now, if you were tasked to do a determinant for that one, what would you say it is? What would you choose to figure that determinant? Excuse me. Okay, either the first column or third row. That would be my choice. Most zeros. So pick one. I don't care. First column. Okay? So the determinant of A will be, we're going to pick the first column, and let's put the first entry in that. And what would that be? What is the position of that 2? Positive position. So that's going to be 2 times, and what do you have left? Negative 3, because your down diagonal here is 0. Or your up diagonal is 0. Down diagonal is negative 3, up diagonal is 0, so it's minus 0. Okay? First one's done. Okay? Let's do the second one. Oh! There are no more, are there? Because those are zeros. So that's it. Now, okay? That's what we chose. Or we could have done it 3 by 3, because this is it. But it's so easy to do this one. What did we just multiply? This times that. Because remember, this gave us a 0. So it's just 2 times minus 1. So guess what? On any triangular matrix, upper triangular, lower triangular, or diagonal matrix, the determinant is just the product of the diagonal. Doesn't have to be a diagonal matrix for that to be the case. Any triangular matrix, upper, lower, or that, it's just the product of the diagonal. Now that's pretty easy, right? You don't have to do your 3 by 3s. You don't have to do, you just do the product of the diagonals. Okay. So that leads to theorem 3.2. I think I will write it here. I think we've got room for it. If A is a triangular matrix, okay, of course it has to be square, right? Triangular matrix of, I can't write, order n, then the determinant of A is the product of the diagonal entries. Right? Oh, okay, let me make that. Is the product of the, let me say it a little more precisely. A product of the entries of the main diagonal. I don't want you going in there and going to the secondary diagonal. Main diagonal is upper left to lower right. That's what we usually refer to as a diagonal. It's the main diagonal. Don't do it this way. Those will always be 0, because if this is a triangular matrix, that lower corner or upper corner one is going to be 0. So, yeah, that wouldn't work. Okay. So, here's how we express it. The determinant of A would be A sub 1, 1 times A sub 2, 2 times A sub 3, 3 times ... times A sub n, n. Okay. Now, if any of those diagonal entries is a 0, determinant of your whole matrix is a 0. If it's a triangular matrix and its diagonal has a 0 entry, then the determinant is 0, which means it's a singular matrix. Okay, not non-singular. Okay. We'll get to that later. Don't sweat it now. All right. Let's do a new matrix A. Okay. Example 6. Yes, I'm hungry. A is equal to this matrix here. 2, 0, 0, 0. 4, negative 2, 0, 0. Negative 5, 6, 1, 0. 1, 5, 3, 3. Okay. A few things to note. It's a square matrix. What else to note? It's a triangular, a lower triangular matrix. So it seems sort of strange to say, it's a square matrix, but it's a triangular matrix. Well, wait a minute, triangles aren't squares, but you know what we're talking about, okay? And it is lower triangular. So, what's the determinant of A? How much room are you going to take? You just multiply that diagonal. Main diagonal. And what's that? First, you notice there's only one minus sign, so it's going to be a minus. And then what you got? Second?
Oh, okay.
12. 2 times 2 is 4 times 3 is 12. Minus 12. Didn't take much work, did it? Okay? So the determinant of a triangular matrix, whether it's upper, lower, or diagonal, it's always going to be the product of the main diagonal entries. That finishes 3.1. Homework exercises here would be any of the odds 1 through 11. They're all found at calcchat.com. 13 or 15, they're both at calcchat.com. 17 should be at calcchat.com. Any of the odds 19 to 31 should be at calcchat.com. 33 should be at calcchat.com. Either 35 or 37 should be at calcchat.com. 39 or 41 should be at calcchat.com. There's a true-false 43 should be at calcchat. 45 or 47 should be at calcchat. 49 or 51 should be at calcchat. 50, any of the odds 53 to 57 should be at calcchat. 59 should be at calcchat. Any of the odds 61 to 65 should be at calcchat. 67 should be at calcchat. 69 should be at calcchat, and that's it. All right. Now, any questions before I erase this? All right. What we got? Couple minutes?
3 to be exact.
3? Let me at least introduce you to 3.2. Okay? 3.2 is determinants of elementary row operations. Okay? And they start with a question. Here's the question. Here is, we're looking for the determinant of A, and the determinant of A would be this. 1 minus 2, 3, 1. 4, negative 6, 3, 2. Negative 2, 4, 9, negative 9, negative 3. And 3, negative 6, 9, 2. Think that determinant's going to be pretty easy? Might be relatively easy, but it's going to take you a while. Okay? Here's a B. Okay? Determinant of B is the determinant of 1, negative 2, 3, 1. Which you may notice is the first row of the previous one. Okay? 0, 2, negative 9, negative 2. 0, 0, negative 3, negative 1. And 0, 0, negative 1. 0, 0, 0, negative 1. Which of those is easier to determine the determinant? B for sure, because it's a upper triangular matrix. What's its determinant? It's what? 6. Okay. Now, because that first row is the same, that looks a little suspicious, but let me suggest something to you. What if we had done an elementary row operation on this one? Multiply this one by minus 4, add it to that, and what would you get? 0. Uh, 8 minus 6 is 2. 2, 0, 2. Minus 12 plus 3 is minus 9. Woo-hoo. And minus 4 plus 2 is minus 2. Hey, that worked. Okay. And I'll just tell you, we don't have time to do it. You got that from doing elementary road operations here. Okay. Well, does that mean anything about the determinants? That's what this section is going to show. Okay. So we'll stop right there, and that's where we'll pick up next time. We will pick up with, we will actually do A, okay? And it's going to take us a little while, okay? But we'll do it, okay? And we'll see if it comes out. Any questions? Okay. I don't think we have enough to do anything on 3.2, but we'll start in 3.2 next time. All right, good deal. Yes? We'll say that one more
I
time.
might not be in attendance Thursday because of stuff at work.
At work, okay. Okay, I'll try to remember to record it. I always do, but there have been a few times I forgot to turn on. Say again?
I'm gonna try my best to get back.
Okay.
I won't be able to make it in time.
Right. Okay. Good deal. All right.